Guys, so I'm going to redo the problems that we already did in class. So this question is asking us to find the length of the minor arc, and the minor arc would be the piece of the arc, and that's right here. And the formula you would use would be the degree, which is the central angle, over 360 times 2 pi times the circumference, and times the radius, and I'm using the circumference, so the formula is this, x over 360 times 2 pi r, which is, since this is an arc, we're dealing with the circumference. So now that I have all of that information, I want to show you two ways to get the answer. So you could use Desmos to type this in, and you would get 3.25, so the arc length is equal to 3.25 pi, or that's the exact answer. Or you do 3.25 times 3.14, which is equal to 10.205, and this is going to be in inches because circumference is a linear unit. Okay, so now this one, the second one says to find the area of the major sector. So major means bigger. Of these two sections or sectors of this circle, this is the bigger piece. So it wants me to find the area of that piece. In order for me to find the central angle, which is this part right here, I would need to do 360 minus 135. So is 225, so this angle right here is 325, and the formula for this would be x over 360 times pi r squared, since they're asking me for the area of this sector here, so it's asking me for the inside, so I would do 225 over 360 times times pi 14 squared. So you can do decimals, type this in, times 14, hold on, times 14 squared would give us 122.5 pi. That would be the area of the sector. That would be the exact answer, and to get the approximate answer, we would do area of the sector equals 122 times 3.14, which would be the area of this sector, is going to be equal to 385.65, and we're going to say inches squared. All right, so this last one, it says a 60-degree sector of a circle has an area of this much. Find the radius. So here I would draw that circle, and it tells me that it has a angle of 60 degrees, which is that central angle right there. And then it's telling me the area of this sector, which is how much space this is taking up, is going to be 52.36, and it wants me to find the radius. So I would use this formula, the area of a sector, and I'm going to work backwards. So area of a sector, so I know that the area, so I'm just going to substitute in, I know that the area is 52.36. The degree here is 60 over 360, and I'm trying to find the radius. So here I'm going to have to use some algebra, and if you need this part, just rewind the video and go back. So I'm going to have to use some algebra here. So I'm going to do 60 over 360 pi r squared, and I'm using the symmetric property of equality to flip this around. I'm going to multiply both sides by 360 so I can get rid of that fraction. So that's gone away, so I get 60 pi r squared equals, then I'm going to say 52.36 times 360 is 18849.6. And then from there, and you can use decimals to help you with the calculations. Then divide into 60 pi, and we get r squared, which is equal to 100 0.0. And then if I take to get the inverse of something squared, it means to take the square root. So that means the radius is equal to 10. And the units here are, it's going to be 10 centimeters. So R equals 10 centimeters. And you can always substitute this back in and see if you got the right answer. All right, so use this to try the next 3 problems, and I'll see you in class. Bye.